Greetings. Let us review the anatomy of the stomach, and these are my acknowledgements that you see here. I want to thank Dr. John Stoline, Mr. Charles Butt, MD Anderson Cancer Center Bootwalk Grant, Ms. Sanjay Suresh, Ms. Angela Deal, and my institution. And these are our learning objectives. So when you do endoscopy of the stomach, it's important to learn the different segments of the stomach, and let us learn about them. Here is an image of the gastrointestinal tract. And when you perform endoscopy, i.e. esophagogastroduodenoscopy or EGD, the endoscope comes down the esophagus, enters the stomach, goes into the duodenum, and then as we withdraw, we examine the duodenum, stomach, different segments of the stomach, and esophagus. So let us learn about the anatomy of the stomach. So the stomach is connected to the esophagus at the GE junction. And once you enter the stomach, the first portion close to the GE junction is known as cardia of the stomach. And then if you turn to the left and up, you see the fundus of the stomach. And as you come down, you enter the body of the stomach that is bounded on the right side by lesser curve that goes from the GE junction all the way to the pylorus, and on the left side by greater curve of the stomach that goes from the fundus all the way to the pylorus. So the body is bounded on the right side by lesser curve, on the left side by greater curve. How do you identify the body of the stomach? It has longitudinal folds known as rugal folds that go all the way from the fundus to the end of the body of the stomach. And as you go down, you see the antrum. Antrum has no folds. It is featureless. That's how you identify the antrum compared to the body of the stomach, which has a lot of acid-secreting rugal folds. And what is the boundary between the antrum and the body of the stomach? That is the angularis, or sometimes known as incisura angularis. And above this is the body of the stomach, and below this is the antrum of the stomach. And the antrum opens into the duodenum through the pyloric canal and then the duodenum. So the duodenum has multiple segments. D1, otherwise known as the bulb, which has no features. Similar to the antrum, it is featureless, no folds. And then when you enter the second portion of the duodenum, you see circular folds, and into the second portion of the duodenum, otherwise known as D2, the bile duct and the pancreatic duct open, and you will see the ampulla. The third portion of the duodenum is known as D3, that crosses in front of the blood vessels and then winds up to D4. So now let us look at the blood supply of the stomach while we are learning about the anatomy of the stomach. So let us talk about the blood supply of the stomach. The first branch that comes out of the aorta is the celiac trunk, and the celiac trunk supplies the stomach. And it has three major vessels. And the first one is the left gastric artery, which supplies the stomach as well as the lower portion of the esophagus. The next one is the splenic artery that goes behind the stomach, and sometimes the splenic artery could be seen as a bulge in the upper portion of the body of the stomach, and sometimes people may mistake it that there is a mass there. I've done that before. And the celiac artery supplies the stomach through posterior gastric artery branches, as well as short gastric arteries that supply the fundus, and the left gastroepiploic artery that supplies the portion of the greater curve. So we talked about the left gastric artery, the splenic artery, and now the porta hepatic artery, or the main hepatic artery, proper hepatic artery, or the main hepatic artery. From there, you get the gastroduodenal artery that supplies the greater curve of the stomach via the right gastroomental artery. In addition, the right gastric artery also comes from the proper hepatic artery and supplies the portion of the lesser curve of the stomach. The stomach has a rich vascular supply with anastomotic branches coming out from the left gastric, splenic, gastroepiploic, etc. So the anatomy of the arterial supply of stomach is important when it comes to control of bleeding. The interventional radiologist tries to get into these vessels and try to plug the vessels to stop bleeding. So now let us move to the venous drainage of the stomach. So let us see the different veins of the portal venous system that allows the drainage of the stomach, small intestine, and colon. So the first big vein that goes from the spleen is the splenic vein that joins the superior mesenteric vein that basically drains the small intestine and portion of the right colon, and they form the portal vein, and the portal vein enters into the liver. Before it enters into the liver, two main tributaries join the portal vein. One is the left gastric vein, and another is the right gastric vein. They join the portal vein, and the portal vein goes into the liver, and then again divides into multiple branches and tributaries and supplies the nourishment to the liver. And from there, again the tributaries start joining to form the hepatic veins, which in turn join the inferior vena cava, and the inferior vena cava enters the right atrium. So when you look at the liver, it has a rich vascular supply. The portal vein divides into smaller veins, capillaries, and goes around the liver cells and lobules, supplying nourishment to the liver, and then the blood, as it goes out of the liver, forms hepatic vein. And when the liver is deranged and develops what is known as cirrhosis with the development of nodules, the pressure in the sinusoids increases, and portal hypertension develops. So there is impaired flow of blood when the liver gets disorganized, as it happens in cirrhosis of the liver. When cirrhosis of the liver happens, the blood, instead of going from the portal vein to the liver to the hepatic veins, it reverses its flow and leads to the development of varices. So these are just the basic concepts of the anatomy of the stomach, as well as the vascular supply of the stomach and the venous drainage of the stomach. I hope this is useful. Thank you.